I'm Jayesh. I work as an AI engineer at Composio. And today I'll talk about building smarter coding agents using Elasticsearch. What we'll talk about is Rube specifically, and I'll tell you what coding agent part gets involved in Rube as well. So I'll quickly start off. I'll go on to the next slide. Yeah, so I think, as I said, we'll start off with introducing what Rube is, first of all. I'll give you a very short brief on that, and then I'll tell you what the memory component is in Rube, how we use memory there. We have two sorts of memory, which I'll walk you through, and whatever we used in behind the scenes, so you get some ideas on it. And then I'll quickly show you a demo at the end of how Rube works and how the memory as well interfaces with Rube. I think to start off, what is Rube? It's essentially an MCP server, like a universal MCP server, which can help you accomplish tasks across n number of apps. How many of you here have used MCPs before, or have heard of MCPs? Yeah. Okay, a lot of people have heard of MCPs. How many of you have used MCPs actively? Okay, perfect. So there's some discrepancy between people who know what MCP versus people who actually use MCPs. I think a lot of challenges why people don't really use MCPs so much. And personally, myself, I haven't really used a lot of MCPs because, let's say for any purpose, let's say if you want to use Linear, for example, or GitHub, you have to install that MCP server into your MCP client, whatever client is, maybe Cursor or whatever. And then after that, you also authenticate, for example, using OAuth API key, and then you can start using it. But let's say if you want to use another app, you again go to the whole same process. You go to that website, get the MCP server in, install that to the client, and then go on and on. So the whole problem is that there's a lot of installation problem between you trying to use an MCP server, which is why people don't use it so much. What Rube does it cuts all of that process into a small process because all you need is just one MCP server, and Rube internally routes your request to n number of different MCP servers. So I'll show you there towards the end of it, and then show you the demo. But essentially, that we have around 700 apps that Composio provides, and then what you do is you just say, okay, I want to do this. Look at linear issues and go to GitHub and create issues based on that, and it will be able to do that by itself. It also handles the authentication layer for you. So now this is what Rube does. Very short primer on what it is, and what I'm going to talk about today is what memory does to Rube. So since Rube is an MCP server and you talk to it through multiple clients, let's say Cursor or whatever, I think myself I mostly just use Cursor client, but I think people use also Cloud, Desktop, multiple other MCP clients as well. But the idea is that when people talk to this client with Cursor or whatever other client, you need to have some memory of what the user is saying. So Rube is not just like an MCP server which performs actions across a number of apps. It also helps you deal with large context. For example, let's say if I ask Rube, look at all of my 1,000 emails or all of my emails across wherever the lifetime of my Gmail is, and then count the number of times, let's say, Soham or Gyan messaged me. So it'll then use its own coding prowess. So what it'll do is it'll first make an API call to Gmail, get your emails, then it'll write code to process that response. Because let's say the response is very huge. It doesn't really put that into the LLM context altogether. It writes it to some file in some remote machine, and then it writes code to process that specific data. For example, in this specific example, if I ask about all of my emails, it will take those emails and then put them in a file in a E2B machine that we have internally. And then it will write some code to process. For example, it'll write a JQ query. It'll try to perform some operations. And then it interlaces those operations with other API calls. Let's say if I ask about GitHub as well, so it'll make a call to GitHub and then get some data from there, and then use that in its own coding process to get you the right result after that. So essentially what it does is not just API calls, but also code execution. It writes its own code as well. And it handles large context information also. So now what happens when you do operations like this is that you run into two problems. First, let's say when you write code, you have to write code specific to a given app. For example, let's say if I'm talking to Linear in this example, Linear's response might be in a certain format. Like it will have a JSON which has some keys and all that XYZ. But let's say if I talk to GitHub now, GitHub will have a different response scheme altogether. So the LLM must be smart enough to know, okay, if I'm making a linear call right now, I'll have to process this response in a certain specific way. Let's say sometimes the response is too huge to be processed by a certain function, for example. So all of this information, all these nuances specific to apps need to be stored somewhere for the LLM to not make the same mistake the next time it writes code. For example, let's say if I made this query right now, and then sometime in the future, maybe you make a query as well. What will happen is Rube will remember, okay, the last time I wrote this code, there was a certain problem that happened. Now I won't make the problem again. So that's one, which is the code memory part of it. And the second is the app response cache. What I mean by that is, let's say if I ask Rube to, again, let's say list all of my linear issues. To make a call to linear, it needs to know my linear user ID. I just can't say, find all the issues assigned to Jayesh. It needs to know what ID does Jayesh correspond to, right? So the first call it makes is a linear list users call. It lists all the users in my organization, in my team, stores the IDs somewhere. Okay, Jayesh belongs to tool engineering team. The team ID is this. Jayesh's ID is this. And then after that, after it has found all the IDs, the next call it makes is for list in issues, whatever, right? So what I want is, since it's already performed this operation once, like it has already made the call, gotten all the response back, why should it make another call in the future when I ask for the same query again? Let's say even if I ask for my teammate, let's say if I ask, okay, get me Venkat's issue instead, it should not make a linear list users call again to get all those IDs, right? So these are two different types of memories that we have to work with. Any ideas on like what kind of memories we can use? I think all of us are pretty much familiar with Elastic somewhat here and there. So I would like to like just throw a question in the room. So I have two use cases. The first, as I said, is a code memory, where I need to know what mistakes the LLM made the first time it wrote some code specifically, and I can use that when it's writing code again. And the second is an app response cache, where let's say I cache important tool calls. Let's say linear list uses an important tool call. GitHub list uses an important tool call. I need to cache those responses so the next time something like this happens, I can easily pick up the ID from there. So what would you recommend, like given the stack that we have, given Elastic Stack, what would you recommend I choose for code memory or app response cache? Like what type of memory would it work with? Any ideas? Like throw random stuff at me, come on. Some ideas for code memory? Nope. Cool, I think I'll just like walk you through it myself. So I think, as I said, the code memory would be, just to reiterate what I said earlier, a tool fails, I save a short tip. Okay, this is how it failed. And the next time I run, I just like, the tip appears for the agent. And for the app response cache, the first time you run this specific important action, you save the whole thing into a cache. And the next time it runs, you just take the cache from there and then you can use it after that, right? So now, the code memory part is where I use semantic search, right? Because why semantic search, right? Like why not something else? Because right now what I do is, let's say whenever code fails, something like maybe the response type was not right or some other problems, like a lot of other problems that the model faces, what I usually do is I make the LLM write a series of instructions for later. So let's say I wrote some code once, I ran that code, it ran into some error. I've instructed the LLM to, okay, take that error response, diagnose what happened, what went wrong, and then prepare a series of statements based on that. And then I dump this into my agent memories index. So here's what the stack looks like. So I have one index called agent memories. It has these different types of parameters. So the most important parameters here is text and ml.tokens. So right now, like, I'm using a previous like older syntax. I'll also tell you what the new syntax looks like. But what happens here is I have one index called agent memories. And whenever I want to store some important value, I just call the /doc and I give it a pipeline. The pipeline, are people familiar with what ELSER is and like what ELSER pipelines are? In just pipelines? No, I'll just quickly give a quick briefer. ELSER is like the semantic search side of Elastic, where you can have, let's say, learned sparse vectors. And what I mean by that is, let's say, in a very simple format, you give the agent, you give the pipeline a text, for example, whatever the text was, diagnosis of the whole thing. And what happens in the background is that Elastic will run a pipeline. It will run like a model called ELSER v2, whatever model it has, or you can specify your own model as well. But what happens is that it runs a model on that text, which converts it into some weighted tokens, essentially. So like, just like vectors, but like it's a bit different than dense vectors. So what happens is I give it the text, which is the text part of my index. And what happens is it converts it to ml.tokens. So it runs this whole process in the background and creates this token based on my text. So what happens next is when I query it. So let's say in the future, whenever my agent wants to learn about whatever happened with the specific code, I just query the text expansion, and then I queried on the ml.tokens parameter. And this ml.tokens is what stores all of my embeddings essentially, right? And what happens is like I query it based on a given text. The text is taken, it is converted again into those sparse vectors, and the vectors are matched against whatever happens to be stored on Elastic, and then I get the result back. So I think what happens right now is like the syntax has changed a bit. So you don't need a pipeline anymore. You can just specify, let's say, the text to be a semantic search type instead of whatever this is right now. So it's a bit older syntax, but I think I worked with it because I started off working on this a while back. But okay, whatever. The idea is that what Elastic helps me do is, instead of just matching with specific keywords, for example, if I store seg fault, or if I store, okay, memory was too huge or whatever, it doesn't have to be matched with the exact keyword. What will happen is the expansion thing is what enables us to also expand this beyond the specific word. For example, if I say segfault, it can expand that specific term into n number of other keywords, and then it stores it into Elastic. So for example, in the future, when anything similar pops up on my agent's memory or radar, it will then be able to match it very properly with the stored vector embeddings, for example. So that's what helps me. So I think code memory is where I use semantic search, all in all. The benefit also with code, with using ELSER is that I can also pair it with BM25, or I can pair it with exact keyword matching also. So right now it's just semantic search because I just convert my text into embeddings and then do an embeddings matching and then get the result back. But I can also pair it with actual keyword matches. For example, the right keywords are matched to the right keywords already. So like more non-semantic search as well. I can pair it very easily on the Elastic side of things. But any questions so far? Any questions around what ELSER is, how we use it, and why we use semantic search for this specific use case? No? Perfect. Okay. So now I'll move on to the app response cache. Now this is a different problem altogether, right? Like I don't want to have, let's say, a semantic search here. Any reason why you can think of why we don't use semantic search here and why we use just a key value matching? Any ideas? Nope. Okay, I'll tell you. So what happens is, like in this case, what I'm storing is actual JSON responses. So when I call a specific API, let's say linear list users, it gives me back a whole JSON of names, IDs, and whatnot, other metadata information, right? There is no way I can store this in a semantic way, right? Because what is semantic searching anyways? Semantic searching is when you dump data into like an index, which has some semantic meaning. For example, maybe natural language text. Let's say if I say Jayesh likes to play basketball, for example, that's the natural language sentence. So in the future, when I say anything around basketball, the memory will retrieve Jayesh likes to play basketball, right? Because it matches basketball into, like, maybe if I say what do I like to play, then it matches play with basketball because these are semantically closer terms with each other, right? So that's what semantic search is for. You take all of your data, you dump it into indexes, and then anything similar to that data, you can match it with it. That's what semantic searching is, right? Imagine that specific, whatever workflow I described right now, would this even work if I, like, say, dumped a whole JSON into my indexes and then I asked for specific? It won't really work because JSON has strict key value pairs, right? For example, imagine a very simple JSON, key Jayesh playing basketball, whatever. And then if I ask it for a very specific term play, it's very hard to match this one natural language word with the whole JSON schema, right? It's not really hard. It's not really easy to do that. So what we do is here that instead of doing semantic search, I just take a key, I construct a key based on my tenant, app, action name. So this makes it a bit unique. So for every user, I get a different key. And then I take this key and I dump the whole response into that key. So what happens next is, let's say the next time my user wants to do something like this, let's say for app could be linear, for example, and action could be list users. So whenever my app recognizes that I need to, again, list all the issues, it will look at this key, to construct a key like this, and it will get all the responses back. So n number of responses which I cached, I can get all of them back into the LLM context. And then I can add an LLM layer on top of it, which can read this whole context and give me the relevant information out of it. So I don't dump the whole thing as well. I don't dump the whole responses. I make a small LLM, SLM model, which we saw earlier. So I make a small language model, which can just take the whole JSON dump from the previous executions, convert them into whatever memory I need, and then put them into Rube, for example, right? That's how it works. So that's the behind the scenes working of how it works. There's like, there's a main code memory, which is semantic search, and this is app response cache. So now, like, why Elastic? There's also, like, we can also use Redis for it, but Redis just provides you with basic, very sub-millisecond fast searching, fast retrieval, but there's not enough search functionality involved. There's not enough semantic search involved. That's why I use Elastic. You can also talk to me after the talk about how it works. But right now, I think what I'll do is, before I do this, I can switch back to my laptop a bit. And as it runs, I can take questions also on the fly. I think we have the last 5 minutes to us. So I'll show you how Rube works. I'll show you how the memory works in Rube. And meanwhile, we can take questions as they come. Okay. So I think I'll quickly switch to Rube. This is the app. 1 second, let me see if I have connection. Yeah, perfect. So I think I would encourage all of you to try Rube.app out. It's like super nice to see it work. But for that to happen, I want to ask you to give me a query. So like you have access to n number of apps. You have access to Linear, Slack, GitHub, whatever. Give me what your use case looks like. So what do you usually do that you would want to be automated? For example, I'll give you an example to start with. Let's say I have linear issues, I have GitHub issues. They're never in sync. So like most of the times I have to like update them myself. So I can just ask it to look at all my linear issues, look at my GitHub PR issues, and then make them synced. For example, if I closed a PR, my linear issue should also be updated to be done, right? That's one thing I do. So give me any use case across n now. It could be like a stupid idea as well. It doesn't have to be super nice. Just give me any random query that you want to see to be done. Any takers? Yeah, go on.
My understanding is right, but let's say I have a meeting in my calendar
Okay,
and something on my to-do list like Google Keep.
correct.
So if I get my meeting done, the Keep should be updated.
Yeah, perfect. I think that also works. Let me check if I have an app for Keep. I don't think I have an app for Keep. But what we can do is we can say, look at my calendar. If you find any meeting, send me an email about it. Something like that. So I'll use calendar and Gmail. So I can ask, look at my Google Calendar, and if I have a meeting today, send me an email about it. Yeah, my internet is a bit slow. I think Whisper won't really work. I use Whisper Flow for transferring all of my voice to text, but it requires, okay, look at my video today, send me an email. Okay, perfect. So when I do this, then Rube will now try to search for all the tools it has available. So it has access to 700 different apps. So you don't have to worry about configuring servers yourself. So this is the client version that I'm using. You can also use it in Cursor. So if you go to Cursor, you can just install. So it already completed research. I'll come back to it here. But you can install the MCP server in your Cursor client, whatever client you want to do. But here you can just quickly chat with it as well. So it says, I'll help you check Google Calendar tools. So when you look at the search tools, you can see it already has a use case, it has known fields, and the result will give you all the actions it has to call. So it first calls list calendars. It then calls, let's say, whatever apps it wants to call, XYZ, doesn't matter. So now it already has a plan for doing it. It's now trying to fetch today's calendar image from the primary Google address. It already did that, I think. And now it found me meetings for my calendar today, and it's trying to send me an email with the meeting details already. So it works across n number of apps and does it. Ever any questions as it works? Any questions so far for MCP? How we use Elastic, Rube?
Maybe let's start with saying who is using LLMs right now in your production? Any show of hands? What do you use for? Why do you use for?
It's basically around speech to text and text to speech.
Okay. Okay. So basically, what you did here, maybe the previous session that we were talking about.
It was a little more.
Exactly. Exactly. So how you incorporated, as you see here, now we are using MCP to make sure we are connected across other tools as well, and we are leveraging. Are you using any MCPs from there?
Not in production, but we are doing some POCs that we will be soon integrating.
Okay. Perfect. Anyone else who has experience working on LLMs and making sure you are using memories and code cache?
So not so LLM we are using Anthropic. So that is for a telecom customer where we want to. It's a customer experience. So now to improve on it. So we are using Anthropic one.
Okay.
But, yeah, it works. But I think like you should give Rube a try. I mean, it works with whatever client you have. Anthropic doesn't matter. It's just an MCP server. Like it's a server which handles your queries, and it can like work across a number of apps. If you go to the dashboard, you'll see like any number of apps you want to work with. But here, I think just to bring it to completion, it did that. It found my meetings and sent me an email already. So email sent to Jayesh at Composio already. So if I go check my email, I'll already find it there. So it works like magic. It's very fast. It just knows how to do it. Works with authentication as well. It's pretty nice.
So it also send an alert. For example, somebody like cancels the meeting. So do you need it to?
Yeah, you can make it do whatever you want. Let's say any operation across n number of apps you can make it work with. That's the idea. So like all the apps here you see, you can get it access to like 700 different apps. You can like just say, look at my super base, find my table, make a summary, send it to Notion. It can just work across n number of apps, do the authentication for you, XYZ. So it can work across all the apps you have without worrying about anything. It manages the auth for you as well. So you have to only log in once, and then after that it manages the login for you. That's the idea.
Thank
you so much.
Thank you so much.